In ANSYS 2023 R1, the Fluids product line is pushing the envelope of performance, fidelity, sustainability, and productivity for computational fluid dynamics simulations. The full release of the multi-GPU solver in Fluent is unleashing the power of multiple GPUs for a broad spectrum of applications, and the accurate hydrogen modeling throughout its value chain is helping to address comprehensively the sustainability challenges in transportation and energy industries. Workflow and automation improvements across the entire product line are resulting in faster, more efficient simulations, thus reducing the design cycles. You can now run a broad spectrum of complex industrial applications natively on GPUs, substantially reducing solve time and total power consumption, with the results showing 6N GPUs providing the same performance as more than 2000 CPUs. This full release added support for non-stiff reacting flows, species transport, and enhanced numeric for LES simulations. Support for sliding mesh and compressible flow simulation has also been added in addition to the fully released features. The new electrolysis models for green hydrogen production and the extended models for hydrogen consumption in fuel cells enable accurate hydrogen simulations throughout its entire value chain. A new embedded PyConsole brings PyFluent directly into the Fluent interface, with support for centralized Python journaling, full-scheme TUI to Python journal translation, and usability features like autocomplete, a quick search of Fluent's command. A new virtual blade model includes the effects of 3D rotors as momentum source terms in the governing equations, increasing automation and productivity for aerospace and energy applications. You can now access high-speed numerics within the Fluent Aero workspace with seamless setup and improved robustness and convergence for all flight regimes. You can now compute the optical path length and optical path difference due to aero-optical aberrations directly in ANSYS Fluent and export them to Optic Studio for more sophisticated optical analysis. A new embedded workflow for parametric design optimization and morphing enables to run parametric studies and design optimization, including morphing, directly within the Fluent interface, thus speeding up design cycles. You can now perform advanced electronics cooling analysis that can include condensation, evaporation, and more with the new direct ECAD workflow for printed circuit board that enables the import of an ECAD directly from the Fluent interface without additional software required. And you can now generate photorealistic renderings of your simulations with the live preview, custom environments, material editor, and lights preset with the new Osprey ray tracing engine available in Fluent. You can now add blade blends, create partial tip geometry at the hub and shroud, and adjust the blade stagger angle directly in TurboGrid. You can use profiles and curves as input geometry, and then TurboGrid will automatically create the high-fidelity CAD with the additional blade features and produce a high-quality mesh. And the new plugin streamlines the workflow for using the CFX solver in OptiSlang, enabling to run design points concurrently and to leverage OptiSlang's parametric licensing. A new arc channel tracking spark model in ANSYS Forte improves accuracy and enables to capture short circuit and restrike events when simulating ignition and flame propagation in internal combustion engines. A new runtime framework providing time-averaged statistics for any spatially resolved flow variable, improves productivity for large eddy simulations and quasi-steady condition analysis. And the new moving monitor probe with prescribed movement allows tracking properties of a fluid pocket as it moves from the suction to discharge ends in pumps and compressor simulations. You can now accurately simulate Zeldovich von Neumann-Doring explosive detonations with the new end-to-end workflow that includes enhancements in the treatment of the incident shock speed in the Kenkin Pro shock model. And the new plasma multiphase perfectly steered reactor enables accurate prediction of plasma water processes like the carbon-free ammonia production and the removal of toxic substances. You can now accurately capture local blockage and flow redirection to uncontaminated parts of wire mesh screens with the new screen icing model accounting for total pressure losses in fence-up ice. You can now perform what-if studies, sensitivity analysis, build custom design of experiments, and more with the new multiphysics parametric exploration in fluent icing. And you can perform steady-state simulations of electrothermal and hot air anti-icing systems with a simplified workflow directly in fluent icing. The rendering improvement, including lighting presets, light attenuation, and SPH, Osprey rendering, increase the end-user productivity and usability when using ANSYS Sensight. And the Osprey engine can now get lighting instructions to ray trace the geometry from HDRI images for a more realistic rendering of simulation results. In this new release of ANSYS Rocky, we have a fully integrated smoothed particle hydrodynamic solver with a unified user interface to set up SPH and EM models in the same environment. The new release provides an efficient simulation workflow for modeling particle laden-free surface flows and adds heat transfer between particles, fluids, and walls. And the simulation domain flexibility has been extended to include inlets and outlets for both particles and fluids, providing more flexibility to set up DM and SPH injections. And the two-way Rocky fluent coupling is now available directly in ANSYS Workbench, with more accurate heat transfer calculation between particles and walls.